Good morning. I am Dr. Sushmita, Assistant Professor of Civil Engineering Department. I am going to deal with multimodal transportation engineering, which consists of highway engineering, railway engineering, geometric design of railways, airport design, and basics of harbor engineering. In this module, I am going to deal highway engineering. The topics to be covered in this highway engineering, that is module 1, are as follows: critical cross section of urban and rural roads, road ecology, classification of roads based on different criteria, concept of capacity and level of service. So here in this slide we can see the typical cross section of urban and rural road cross section. Okay, so here you can observe carriageway, formation width, total road land or right of way, road margins, setback distance, longitudinal drain, berm, side slopes. So everything are shown in this figure. So these are some of the critical cross-sectional elements of highway cross-section. Right of way, travelled way or carriageway, roadway, median, shoulder, curb, or which bicycle or pedestrian facilities, drainage channels, side slopes and cross slope. Let us see one by one. So first is right of way. So right of way is a term which is used to describe the right to pass over another land. So when the government acquires land for highway purpose, it is actually obtaining right of way over land on which a public road ultimately will be built. So it is a right of the government to acquire any land for public purpose. So every department of transportation will execute this right of way only when it will benefit the public. So the right of way is total land acquired for the construction of a highway. So as per IRC recommendations, if it is a single lane road, then the right of way must be 50 to 100 feet width. For two lane roads, right of way must be 150 feet width. For four lane roads, it is 250 feet width. For 8 lane roads, it is 300 feet width. So next is travelled way or carriageway. So carriageway is nothing but a portion of roadway which is provided for movement of the vehicles, excluding the width of the shoulders. Okay, so number of lanes on a travelled way are decided based on the expected traffic volume on that particular road. So here in this road, it is marked as A, B, C and D. So A clearly indicates roadway, B is carriageway which is actually meant for vehicle movement, C is lane, D is the shoulder. Okay. So as per IRC recommendations, the width of the carriageway for single lane roads is 3.75 meters. If it is two lane road without raised curb, it is 7 meters. If it is a two lane road with raised curb, it is 7.5 meters. For intermediate lanes, that is, so at some places it is not possible to provide two lanes, but there is some space. So in that case, we don't go for single lane road or double lane road. So in between we provide intermediate lane whose width as per IRC recommendation is 5.5 meters. So for multi-lane pavements, we provide 3.5 meters width per each lane. So similarly, the width of the roadway for various classification of roads is given in this table. For national and state highways, major district roads, other district roads and village roads in both plain and rolling terrain as well as mountainous and steep terrain cases. So next is shoulder. So next cross-sectional element is shoulder. Shoulders are nothing but they are strips provided on both sides of the carriageway. So here in this image you can observe the shoulder. So sometimes they will be acting as a bicycle lanes also. So it is provided along the road edge to serve as an emergency lane also. So it acts as a lane for vehicles which have broken down. IRC recommended a minimum shoulder width of 2.5 meters. So it should have sufficient load bearing capacity even in rainy season also, that is during wet weather condition. So the surface of the shoulder must be provided rougher when compared to the normal traffic lane, because in general vehicles are discouraged to use the shoulder as regular normal traffic use. So you can see in this figure, a roadway is nothing but portion of highway provided for vehicular use. It includes both carriageway and shoulders. Next is median or separator. So median is nothing but a physical barrier which is provided between the divided highways, two adjacent roadways. So the main purpose of the median is to prevent head-on collision between opposite moving vehicles. So the width of the median as per IRC recommendations, it is 1.2 to 24 meters depending on the purpose of the road. Next is curb. So curb is the raised portion in between pavement and shoulder. So the main purpose of the curb is it acts as a drainage control. Next is footpath or sidewalk. So footpaths are provided mainly in urban roads. These are raised strips constructed along both the edges of the roads. So the minimum width recommended for footpath as per IRC recommendation is 1.3 meters. So these are traffic barriers. The main purpose of providing traffic barrier is to prevent median crossover, to prevent errant vehicles from going over the side of a bridge structure, to protect workers, to protect pedestrians or bicyclists from vehicular traffic flow. So next cross-sectional element is bicycle and parking lane. So bicycle lane is nothing but the lane which is provided exclusively for bicycle movement purpose. So in this figure you can see the minimum width of the bicycle lane as per IRC recommendations, it is 1.5 meters. So parking lane is nothing but the lane which is exclusively provided for parking purpose. So the minimum width recommended as per IRC is 2.1 meters for parking lanes. Next, drainage channels. Drainage channels are provided along the length of the road by side slopes for stormwater drainage. Next, side slopes. So side slopes of earthwork in filling or in cutting are provided. Side slopes of in general 1:5 to 1:6 are recommended in flat terrains. Next is next cross-sectional element is cross slope or camber. So camber is nothing but cross slope provided in transverse direction on the road to drain off the rainwater is called camber. Okay, so camber is cross slope provided in transverse direction to the traffic. The main purpose of providing camber is to drain off the rainwater. So these are cross-sectional elements. Next topic is road ecology. So road ecology is nothing but it is study of ecological effects of roads and highways. So some of these effects includes air quality, so which consists of both negative effects as well as positive effects. In negative effects, due to the construction of roads, air pollution will be more. Okay, so air pollution from fossil powered vehicles can occur wherever vehicles are mainly used in congested areas. So these emissions may include particulate emissions from diesel engines, nitrogen oxides, volatile organic compounds, carbon monoxide and benzene. So due to this road construction is also having positive effects on air quality. So due to construction of new roads which can divert traffic from main built up areas, so which can deliver improved air quality in the congested cities. So next is hydrology, which is also having negative and positive effects due to road construction. So whenever we construct a road, so due to urban runoff from roads and other impervious surface, it is a major source of water pollution, which consists of gasoline, motor oil, heavy metals, trash and other pollutants. Okay, so it is also having positive effect. So road runoff is a major source of nickel, copper, zinc, cadmium, lead and polyclinic aromatic hydrocarbons. Next, air pollution. So road construction is having both negative and positive effects on noise pollution. So due to construction of a new road, noise pollution may occur, which is a main factor of environmental degradation, which can contribute to numerous disturbances to human as well as wildlife. So it is also having positive effects. So construction of new road, it can divert traffic away from main population centers, which relieves noise pollution. So next, effects on wildlife. Roads can act as barriers or filters to animal movement, which can lead to habitat fragmentation. So the traffic due to weekend tourism could induce changes in the activity patterns of the birds. So road ecology is nothing but a study of both positive and negative effects on various criteria because of roadway construction. So next is road classification. So roads are classified based on different criteria. So first, based on usage. Based on usage, the roads are classified as all-weather roads and fair-weather roads. All-weather roads are the roads which can be negotiable during all weathers of the all weather seasons. Fair weather roads are the roads where there will be interruptions to traffic which may occur throughout the rainy season. So based on carriageway, the roads are classified as paved roads and unpaved roads. Paved roads are nothing but the roads which are provided with a hard pavement course. Okay, example WBM roads, that is waterbound macadam roads, bituminous macadam and concrete roads. Unpaved roads are the roads which are not provided with a hard pavement course, example earth and gravel roads. Next, based on surface finish provided or not, the roads are classified as surfaced roads and unsurfaced roads. Surface roads are nothing but the roads in which the surface finish is provided with at least CC or bituminous concrete finish. If it is not provided with CC or bituminous concrete finish, we call it as unsurfaced roads. Okay. So next topic is concept of capacity and level of service. So a capacity of highway is defined as maximum traffic flow that can be accommodated in a highway facility during a given time period under prevailing roadway and traffic conditions. The units for the capacity are vehicle per hour or PCU per hour. So we have mainly three types of capacity: basic capacity, possible capacity and practical capacity. So basic capacity is nothing but maximum number of vehicles that can pass a given point on a lane or a roadway during 1 hour under ideal roadway and traffic conditions. The units are vehicle per hour or PCU per hour. Basic capacity is maximum number of vehicles that can pass a given point on a highway during 1 hour under ideal roadway and traffic conditions. Possible capacity is maximum number of vehicles that can pass a lane or roadway during 1 hour under prevailing roadway and traffic conditions. So next is practical capacity. So here, maximum number of vehicles that can pass a given point on a lane or roadway during 1 hour when traffic density is not so great so as to cause unreasonable delay or restriction to driver's freedom to maneuver. So different factors affecting highway capacity are width of lane, shoulder width, lateral clearance, commercial vehicles, road alignment and geometry, existence of intersections, one-way or two-way traffic, flow speed, weather condition, parking, and presence of pedestrians. So let us see how these factors affect the highway capacity. So when you consider width of lane, if width of the lane is more, then the capacity will be more. Okay, so if the width of the lane is less, the capacity will be less. That is, the number of vehicles which are passing are less. Automatically capacity will be less. Next, shoulder width. If shoulder width is more, then capacity will be more. If shoulder width is less, the capacity will be less. Next is lateral clearance. If lateral clearance is more, okay, so that lateral clearance will be utilized by non-motorized vehicles as well as two-wheelers, and flow will be more. So if flow is more, then capacity will also be more. So next is commercial vehicles. See, if commercial vehicles are more, that is heavy vehicles, such kind of vehicles, if they are more in the traffic platoon, then the capacity will get decrease. Okay, so because so the space occupied by those vehicles will be more when compared to other kind of the vehicles. Next, road alignment and geometry. If the alignment is straight and it is shortest, then the capacity will be more. If the alignment is longer and it is having some complicated path, then the highway capacity will be less. Okay, so if there are more intersections which exist in some particular route, okay, so there will be more delay to the vehicles and capacity will get a decrease. Okay, see, if one-way road or two-way traffic is there, then the capacity will be less compared to more number of lanes. Okay, so if the flow speed is more, capacity is more. If the flow speed is less, capacity will be less. See, if the weather condition is wet, okay, see, if it is rainy season, the condition of the pavement is wet and the weather is not clear, then in that case the capacity will be less when compared to clear weather condition, that is sunny weather condition. So next, parking. If the number of vehicles which are parking on the roadside are more, then if the number of vehicles which are parking on the roadside are more, that is side friction is more, then the capacity will get decrease. Okay, next, presence of pedestrians. If there are more number of pedestrians which are moving along with the vehicular traffic, then the capacity will get decrease. Okay, and vice versa. So these are some of the factors which are affecting highway capacity. So next we have level of service. So level of service is a qualitative measure. Level of service is qualitative measure of operating conditions in the traffic stream, and it is a perception of these conditions by drivers and passengers, that is road users. So level of service varies from A to F, that is 6 categories, A to F, A, B, C, D, E and F. So level of service A indicates free flow condition, level of service B indicates reasonably free flow condition, C indicates starting point of stable flow, D indicates it is approaching unstable flow, next E indicates unstable flow, and finally level of service F indicates forced or breakdown flow condition. Okay, so these are 6 levels of service, that is qualitative measure of traffic facilities A to F. Thank you.